All right, so today we are covering the last piece. Yesterday we covered 3 kinds of things we needed to know. And to be honest, I felt like we didn't spend that much time talking about the actual test you just got back. So I want to spend a little bit of time on that because I didn't want to record on the video me talking about how to do all the problems from the tests. Okay, but I want to go over that type of question because that is a big part of tomorrow's cumulative is the one you just took. All right, so what was that about? Well, one of the things you needed to know was this kind of a problem. Let's say that you have a pool in your backyard that has an area of 800 square feet. And let's say that you know the perimeter of your pool. You walked all the way around it and you measured it and it came out to a perimeter of 150 feet. Then how long are the 2 sides? Try it. On this kind of a problem, you would probably not have a calculator, but then again, the numbers would have been made so that they would work out nice in factoring, and I did not do that for you. So if you can just set it up, then you're fine. Because once you get it set up, if calc isn't allowed, it's probably going to factor. All right, so your first thought should have been label the rectangle better. X is a good start, but then what's the other side? Hold on. Nope, it's not. Because this X and this X will be the same. This will be 800 over X. That's the way to label it. Because when you multiply 800 and 800 over X, you get 800. All right, now you should set up the perimeter. The perimeter, 2 lengths plus 2 widths. And the perimeter is 150 equals 2 lengths plus 2 widths. You get what I just did here? You get the basics of that kind of problem. And then a lot of kids did get this far and then were stuck. But what was the one thing they had to do and it would have fixed it? Not dividing by 2. That's not actually what we want to do. Thank you for trying. What do you think? Yes, multiply everything by X. Multiply by X here and here and here. Why did that fix it? Because this X and this X will cancel now. Now you don't have X's in the denominator. So it's 150X equals 2 times 800 is 1600 plus 2X times X is 2X squared. Now I just have to put this over to the other side. 0 equals 2X squared minus 150X plus 1600. And again, if I had done this nicely, at this point it would factor and you'd be able to get your answer. What if it doesn't factor? That is a possibility. Then you just got to use the quadratic formula. You stick all the numbers in the quadratic formula. Here's A, here's B, here's C. You stick them in and you get your answer that way. Okay, so the moral of the story is you got a picture, you label it well. We needed that piece right here. Then we needed a good formula, which we start with the original formula and we plug stuff in that we know. And then you end up just having to solve that equation. It's really not that bad when we break word problems down into those 3 steps. Make a picture, label the picture, make the formula, and then solve it. Actually, this first. Once you make the formula, you stick the stuff into the formula. Stick this stuff into the formula. Okay, that's one important thing from the last test. What else was on the last test? Can you name anything else? There's a lot of other stuff. How about that mixture formula? Was that something we studied a lot? Just because it wasn't on the last test doesn't mean it wouldn't be on this test. What's that mixture formula again? Amount 1 and then percent 1 plus amount 2 and percent 2, and then it equals amount 1 plus amount 2, yes. That's total percent. All right, so once you try one of those, let's say I had a 75%. Let's say I've got pop that has been watered down a little bit. So it is 75% pop. And there's 8 ounces of that. 8 ounces, 75% pop. Now, let's say that if you got pop to be 95% pure pop, let's say that research had shown that kids can't even tell the difference. If it's 95%, pop or 100% pop. In other words, if it's slightly watered down, it doesn't matter that much. Evidence, people use ice all the time in their pop. So they don't have to go, oh, my pop's all watered down, right? And ice does melt it, right? So pop that's slightly watered down isn't that bad. Otherwise, nobody'd ever use ice. All right, so how much pure pop should I add to get up to 95% pop? Try to set up the little equation. We want to get up to 95% pure pop. I shouldn't say pure, because 95% means not pure, but 95% pop is what would taste just about as good as real pop. You'd never even tell the difference. You guys notice that some restaurants have better pop than others? You go to some restaurants and then the pop mixture is off. Oh, in my opinion, at least a few of the local Subway restaurants, the pop mixture is terrible. It just doesn't taste like the right pop. Then the ironic thing is they started selling pop in bottles then. So it's like, so you're forced to buy a $2 bottle instead of because their pop mixture is not right. But, it could be, yeah, maybe it's the type of sugar they're putting in it. Maybe it's just the mixture's wrong. Maybe it's the type of charged water, like the fizzy water they use. Okay, 8 times 0.75 plus pure pop. What's that? Well, I don't know how much to put in, but pure pop is 100%, 1.00. And yes, 1 is the same as 1.00. Equals, I don't know how much it's still, but I know it's 8 plus some amount times the 0.95. That's how you'd set it. From there, it's a matter of multiplying it all out. Here, you would probably have to have a calculator. Well, I guess you wouldn't have to. You can use fractions. 3/4. 8 times 3 is 24. 24 fourths. It's kind of a bit of a pain, but plus x. And then I could go 8 plus x times 95 hundredths. Ugh. And then if I wanted to fix my fraction problem, I'd have to multiply everything through by 400. Yuck. Because then I get rid of the 4 and the 100. But I would just use a calculator on this one. Has anybody got it down to what they think the answer was? 32? All right. So when you're all done, you solve it down to x equals 32. All right. Now let's judge that and see if that makes sense. If we put in 32 ounces, that's way more pop than we had in the first place. We had 8 ounces, and we add 32 more ounces. But to get something 95% pure, you have to add a lot of the real thing, right? To get it to be 95% pure. Because if I just added 8 more ounces, it would get twice as pure as it was, but so it would be like at about 80-some% instead of 75. So there was the 25% that it wasn't pop, would be half that much not pop. So anyway, yes, 32 sounds like a right answer. Okay, it's always bigger than you'd think. It's the same problem with kids that have a high GPA and want to raise it more. Do you get how if you have like a 3.9 GPA and you want to raise that, you have to have tons of like higher than 4s, like 4. How do you get higher than a 4.0 GPA? Only with weighted grades. Okay, so that is why it's incredibly impressive when somebody comes out with a 4-point-something GPA, because they had to have pretty much had all 8s. There's a few kids who do it. And not even A minuses. An A minus, it sounds good, but it's way not as good as a straight A when it comes to your GPA. Okay, so let's talk about other things that could be on this part of the test. What else was on there anyway? Yes, a lot of those big fractions with less thans or equal to, like this. X squared minus 16 over x plus 3, x minus 4, and then, all right, let's not do that one. X minus 5. So I'm getting a hole in there, and we didn't even mess with that. Less than or equal to 12. No, it always a 0. Get that. Okay, so tell me, after you factored that thing, You get a bunch of important points. What are you going to do? Put them on a number line. What are you going to do then? Test regions. All right, that's the main thing for that kind of a problem. Do we really need to do the whole process here? I think we've done enough of these. You probably get it. The main point is, let's say you were testing a region you want to test like -5. You need to have it factored first. It'll make it a lot easier. X plus 4, x minus 4. If I put in a 5, you need to know how to test that. And you're really just looking for, is it going to turn out positive or is it going to turn out negative? Positive, 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 positive. No wait, it's 0. What happens if it's 0? What if it happens if it's 0 on the bottom? It's undefined, and those will never work. Those will be U's. Okay? So 5 wasn't even a smart thing to be checking because it was one of my main points. I should check -5. That would have been smart. I think that's what it said, and then you never did that. So just -5 in all these spots. And now I'd say it's negative, 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 and negative. This is a little subtracting problem. It's not a adding, or not a multiplies. So it's all negatives, negative, negative, over negative, negative, and that would end up being positive. Which means that zone would not work because I was looking for things that were less than 0. All right. We've done so many of those that I don't want to continue beating that horse. You heard that saying, don't beat a dead horse. Okay, anyway, let's move on to the next type of test. There's a graphing test that has a lot of important stuff on it. Sketch a possible graph for this. I don't know exactly what it looks like, but I know a fair amount. I am not going to know exactly where its roots are because this one won't factor nice. But give me a sketch that could possibly work. It's all about the zeros, the y-intercept, and how many roots it has. Oh, and the end value too. Like you should know if the thing ends going up or down. Now have your sketch look good enough that I'm going to have you exchange in a moment with somebody, and they'll tell you whether or not yours could have passed. Okay, so sketch it well enough so the kid behind you or wherever I have you hand it can tell whether or not yours could have been right. That'll give me a better judge of whether you really get it or not than just having you nod your head. Because kids tend to want to say that they understood it even if they kind of didn't. Okay, take your possible sketch and hand it to the person sitting behind you. Person in the back row, just save some time and only hand it to the person in front of you, and people who are second to the back will have 2 to grade. It won't be that hard. Okay. Now let's say I was looking at one. Let's say that I had one that was like this. It was going down here and it bounced here and then it went up there. All right. What do you check for? First of all, this one's not right that's on the board. Okay. But here are some things that was right about it. It was going down on the right. Because see, it's positive in the front here. So it should be going down on the right. Look at theirs. See if theirs is going down. Sorry. Up. Up. Okay, so this one is way... How about if I draw one that's right instead of wrong? Okay. It should be going up on the right. It should be going down on the left. Okay, quiet please. Why? It's a good question. Because its lead coefficient is positive. That means that the ending of it is going up. Do you remember that? That the lead number, this number here, if it is positive, that means it ends going up. You have to know that. Next thing is, it's odd. Since it's odd, they must be going in opposite directions. So therefore, the other side must be going down. Nope, nope. To get the degree, you do not add in any other degrees like that. Okay, what you're probably thinking of is if it had been like this, to get the degree, if it's like this, then you'd add the 2 and the 2 and it would be degree 4. Only if it's like this, because this hasn't been multiplied out yet. Okay, back to this other one. So this one is degree 3, so it's odd, so therefore it goes opposite directions. Next thing is, you check for how many roots it has. See this 3 here? That's how many roots it should have. It's 3. Okay, so they could do that with cut through, cut through, cut through. That's an option, but then my y-intercept is wrong. That's another thing. See that? Y-intercept is -9. If their y-intercept is not -9, like mine wasn't, mine wouldn't have worked. So I'm going to show a right one here now. Let's say I have to go through -9. So now I'm going to go down and maybe I go like this. That would work. Or here's option B. I'll make it in green. It's got to end going up this way and it's end this way. So now I'm going to make it go down, go through -9, and bounce, and then go all the way down. That would work. That has degree 2 plus degree 1 makes a total of 3. Another option I'll do in black here is, let's say it went this way and it did its bouncing here, and then on the way down this way it cuts through. It has a y-intercept of -9. All right, so it's a lot of options. All right, here's the next kind. This kind can factor, and therefore you should know exactly how it looks. Try graphing this one. X to the 4th plus 4x cubed plus 3x squared. I know it's going to be depressing, but I want to know how many of you graded a graph that was right? How many of you graded a graph that was right? Oh, that's like 10 of you. That's not too bad. Maybe 11. All right. This one, once you factor it and you set it equal to 0, you'll know what the roots are. You'll know where it touches. You'll know if it bounces there or if it cuts through there. So factor this one. And set it equal to 0. And then you'll know a lot more about how this one would have to look. So you can do a pretty accurate graph on this one. It won't be perfect, but you'll know where it touches. You'll know the roots, the zeros, the x-intercepts. And you'll know whether it bounces there, cuts through there. So for some of you that are really bad at factoring out orange juice, it's going to come up a lot. X squared comes out of average. And then what's left? X squared plus 4x plus 3, and even the second part of that factors. So it's x squared and then x plus 3, x plus 1. So now do you see where it touches? It touches at 0, -3, and -1. 0, -1, and -1. How many of you would have known that? Very good. Next, does it end going up on the right or down on the right? Up on the right. My lead term is positive. This number's positive. There's no negative there. So it has to end going up. Next, at the 0, at this spot right here, it's bouncing because it's square. So it has to be going boing like that. Next, it's going through -1 and -3, and those are single roots. So it's got to be cutting through there. Cut through, and then cut through, and hopefully it's even because they're both going up, and if they're both going the same direction, you know it has to be even. And is this an even degree? Yes, it is. It's degree 4. Notice if I look at this, I'd have to add up the 2 and the 1 and the 1. That's the bad thing. This is degree 4, so it has to be both ends have to be going up. And how about the y-intercept? The y-intercept is 0. Does that make sense? Here's a statement I've told you 1,000 times. The y-intercept is where x is 0. If you put in a 0 here, here, and here, you see the whole thing cancels out and it's just 0. So the 0 is the y-intercept. Okay? That's an important thing to know how to do. There is practice for that on your worksheet. All right, next thing is, given some limits, sketch a graph. I'll warn you, the one I'm about to give you is going to kind of look like that, except it's going to be different than that. Okay? And I'm going to give you the limits for it, and we'll see if you can write it correctly. Everybody, first of all, just to see if you really get limits at all, if I have this graph, I want you to tell me the right end limit. And I should be more clear about, you know what, I did something wrong here. I have to go like that, and I'll have to put in the other asymptote line this way. Tell me the right end limit in limit notation, as in right limit, blah, blah, blah. Do you know how to write a limit? Tell me the right end limit for that. The dotted line there is what it's going to get closer and closer to. You can tell where the right end limit, you won't care what this is, but I'll tell you that that's 1. But the right end limit, that won't matter. That spot right there is 1. And it's relevant in this case, but okay. Here's what I want. Lim of the function as x approaches infinity, that's the right end limit. And then what does it get to when I get there? When I go way over here, this line's height will be, the y, remember I already got the x here, the y will be 0. Because why? Because it gets closer and closer to that line right there. All right, raise your hand if you had that one right. Good. On to, if I give you a bunch of limits, you should be able to tell me what the graph looks like. All right, so I need to, this is really hard to do without a sketch, so I'm going to sketch it behind this whiteboard. I'm going to make it like that. Okay, so now, here's my 4 limits. Limit of the function as x approaches, and then I need an equal sign. Now I use the wonders of technology to replicate that whole thing. First, I group it. That what that noise is interference from my iPhone, or your iPhone. Anyway, okay. Now those are kind of hard to read because they're so close to each other. I'll just spread them out. Okay. It's sort of like having an iPhone detector. It makes buzzing noise when you see it. Yeah, it's receiving. Actually, it even goes and looks for data though, like if it's fetching data. It's good. Okay. So here is my limits. The limit as it approaches infinity is 1. The limit as it approaches negative infinity is 1. The limit as it approaches negative 2 from the negative, see that deal, is infinity. And the limit as it approaches negative 2 from the right side, is positive numbers, is negative. So from that, you should be able to tell me what the graph looks like. My first thought would be try to figure out what the asymptote lines are. Once you get the asymptote lines in there, you kind of know what general shape it looks like. It's not hard. Here's how I think this through. First part, I'd say x going to infinity means when you go way over here, it's going to be close to 1. That means that there's an asymptote right there. 1. So it's going to get closer and closer to 1. All right. Next thing is, The limit as I approach negative infinity is also 1. That means, again, there's an asymptote, and we already knew that. There's an asymptote there at 1. All right, then the other part, you should be thinking, okay, as it approaches negative 2 from the left, that's one of these where it's coming from over here and it's getting closer and closer to negative 2. That means there must be an asymptote line like this. That's positive 2, sorry. Okay, I went a little too far. This line here doesn't need to go that far. It needs to go to negative 2. There's an asymptote line right here. Right there. Okay. And now, you know kind of what it looks like. You could kind of assume that it just goes like this and like this, but you wouldn't want to assume that. You might get it wrong. So you ask yourself, all right, as it approaches negative 2 from the negative, that means as I get closer to this line from the negative, which is over here, it goes to positive infinity. Oh, so as I get closer and closer to this, it's going to go up. It's right there. It must be like that. And then the other part, coming towards negative 2 from the positives, means I'm over here somewhere, and I'm getting close to negative 2. It's going to go down to negative infinity, means it's going down there. Ah, now I see it's this. That's what it should be. Raise your hand if you had that one right. 3/4 of the class. That's not too bad. Okay. Do you get how those asymptote lines were here and there? It's really important. Okay. And which kind of asymptote line? This kind was an X asymptote. That's the kind that's like this. This was like the negative 2 right here. Okay, so this is the X kind of asymptote. And this was where the Y position is. And that's the Y kind of asymptote. Okay, that was this line right here. All right. Last thought. If you were just simply asked to graph this, there's 2 ways you could do it. Number 1, you could know what the parent looks like. Did you get that the parent, if you break this down, is really just 1 over x? Do you know what that looks like? You should know that one. That's this one, the butterfly one. And it goes through 1, 1, and negative 1, negative 1. It goes like that. Remember that one? And then it's just that one, except it's been shifted. Where? 3 to the left, and then what's the plus 2? Up 2. So if I take this, shift it 3 to the left and up 2, I'm going to write that quick. Hopefully they stay together. They did. And now I can move them 3 to the left and up 2. 1, 2, 3 to the left and up 2. 1, 2, 3 to the left and up 2. And there's a little sloppy. That's basically where it would be. Okay, that's a rough sketch. What if you needed exact points? Do you remember my advice on all graphs? You could basically almost cheat your way through every graphing test by making an XY chart. It'll work. It's really, really powerful. So if you're stuck on one, make an XY chart. Because you don't even have to know what the parent looks like. You find enough points and you'll eventually figure out where the graph's going. So what are some points on this one? Well, if I stick in numbers I like let's say I stick in negative 2, then I'll have a 1 on the bottom. That'll be nice. If I put in a negative 2 here, negative 2, I have 1 over 1, which is 1. 1 plus 2 is 3. There we go. There's one of my points. Got to do my graph. And if you check yourself, if nothing else, use this to check your graph and make sure it's in the right spot. Was negative 2 comma 3 one of the spots on my graph? I think it was. And then I try another spot. Like let's say, what if I make this negative 4? Why am I picking that? So that when I add this together, it'll become negative 1. And 1 divided by negative 1 will be negative 1. Negative 1 plus the 2 makes 1. So negative 4. Negative 4. Good. And eventually, if you make enough dots, you'll figure out, oh, look, where my graph is. When you go over and make positive ones, you'll figure out where the rest is. Good. I think I'm doing it right. I'm going to try one more point. Let's say I wanted to try something over here and see where, is it like up here or is it down here? I'm going to try something like, put in a 5. I'll have a 5 here. 1 over 5 plus 3 makes 1 over 8. 1/8 plus 2 is 2 and 1/8. So over 5 up 2 and 1/8. So I kind of assumed where that was going to go, and I assumed it badly. Oh, okay. I just don't have enough points to be able to see where my final answer goes. So I'm going to go back to the other way just to show you that this is right. My other way is that it should look like this, except it's been shifted where again? All right. So I take this and shift it left and up. See how it's now matching? It's really hard to see it. So this is really a better way to test yourself than to try to do the whole problem. So you'd have to make so many points. Eventually, if we'd have made more points, it would have started to look like this. And we'd have been like, oh, dummy, you're putting it in the wrong spot. But if you make enough dots, you'll see where it's supposed to be. All right, that's enough help. Now, you've got a packet which has plenty of practice problems. If you're stuck on any of them, now you've got 10, 15 minutes where you come up and ask me for help. I want to give you a bunch of work time. Please, for your own good, do the packet. I am collecting it tomorrow. I am putting in the gradebook tomorrow, period, because I'll have time. You're going to be testing, so I'll be able to just take them, put them in the gradebook. So get it done. Okay, I haven't got much in that 15% category either, so those of you that need a bump in your grade, you can have a perfect. It's in your control. Okay, so get your homework done. Okay, I want to add one more thing. I just realized. Along with shifting and moving those functions, okay, sometimes they'll tell you, here's where I want to shift it and flip it and move it, and then you have to write the equation for that. So let's say I wanted an equation that had been pushed to the right 5, and it had been stretched 3 times taller, and it had been moved, this is kind of a weird one, but let's say it's 1/2 as wide. And the last thing we'll say up 7. Could you write me an equation for this? It's an absolute value one that's been moved right 5, 3 times taller, 1/2 as wide, and up 7. Not necessarily in that order, but if you have all those pieces, you'll have it. So you write, it starts like this, except you change your equation so that it's going to actually move those places. So you write y equals absolute value of x, and you leave yourself lots of room in there to work. That's kind of how you start. That says 3 times taller. That's 3x. Right 5, 3 times taller, 1/2 as wide, up 7. So if you wanted to move it right 5, you would just have this minus 5. If you wanted 3 times taller, you have a 3 on the outside, because that's the up-down kind of thing. Next, you want it up 7, put a plus 7 here. The only thing I have left is 1/2 as wide. I need a little parentheses in here. And then I put something in front of that, because that's where you put stuff that changes the width. But if I want it to be 1/2 as wide, do I put a 1/2 there? No, because it's counterintuitive on the inside. So I'd put a 2 right there. Squeeze in a 2 in front of that parenthesis. So I'll write the final answer cleaner here. 3 parenthesis 2 x minus 5 plus 7. That would do everything I asked for. Okay, and that's along the same lines as if I told you, here's the equation, tell me where it goes, you'd make this list. If parentheses wasn't there, then it would change everything, because all of a sudden this 2 isn't going to be multiplied by there. So you need those parentheses. Okay, so just have the parentheses, that's all. You can always put in the parentheses. It's not going to be, like it's safest to put the parentheses right there. Because what if you had a parentheses there and you really didn't need them? It won't hurt anything. Okay. So how do you? Are you? I mean, somebody came to the door, was a teacher, and I got distracted. Could you ask that question again? Oh, that's a whole different test. You're thinking of things like this, where you do y equals absolute value of the function. That's not that we did. That wasn't discussed. Oh, it is on the final. I'll help you with it, I guess, if you want to know. It's not on this cumulative test. Get the point across. But if you want to know how to do that, here's if this was the parent function for it. Let's say it was like a little turtle-looking thing. Then let's make it go down like this too, so that you can see what happens if it's underneath the line. Then, if I do absolute value of the function, then I'm taking these are like y's, right? So I'm taking all my y's that were negative. Where are they? Down here. Everything underneath that line. That's where the y's would be negative. And I'm making it turn from a negative to a positive because when I put these absolute values around it, the stuff that's underneath that line has to turn positive. Do you get how that makes the stuff underneath the line right here has to then go up? And that's the final answer. This whole thing except that bottom part flips up. And if the function was on the absolute values on the inside, that'd be the other kind. And then turtle again. Not much like a turtle, but that's okay. And if I do this, you take your function and you absolute value the x's, which means any x that was negative over here has to change. So all this stuff that's over on the left side of this line, that's where the x's were negative, that's all going to disappear. And then how do you finish? You take this and you reflect it across here. It's the Minnetonka M.